Hey guys, today we are going to talk about exponential functions. Some real-world examples of exponential functions are population growth, radioactive decay, and interest rates. This can be interest on a loan, interest that you're paying, or it can be interest that you're earning on an investment. So we're going to start now by graphing some exponential functions. So our first function is y equals 2 to the x power. We're going to make an xy table. And let's start by saying x is 0. Anything in the world to the 0 power is 1. So we're going to have a point at 0, 1. Okay, then we'll go to the first power. 2 to the first power is 2. So we've got a point at 1, 2. The second power, 2 to the second power is 4. So we have a point at 2, 4. Third power, 2 to the third power is 8. So 3, 8. The fourth power, 2 to the fourth power is 16. This goes up to 13, so I'll just make marks 14, 15, 16. Okay, now we're not going to want to go any higher than that, but what about over here on the left side of this graph? So we're going to go to negative 1. 2 to the negative 1 power, and if you're not sure how to handle that, we'll just use a calculator. 2 raised to the negative 1, that's 0.5 or 1/2. So negative 1, 1/2. So right about there. Okay, then the negative 2 power. So we have 2 to the negative 2 power. That's 0.25 or 1/4. So negative 2, 1/4. Getting closer to 0. Okay, let's try the negative third power. 2 to the negative third power is 0.125. If you don't know that as a fraction, math, enter, enter, we get 1/8. So negative 3, 1/8. So we're getting really close to 0, and it's going to continue just to get closer and closer to 0. It's never going to actually touch 0. It's just going to get infinitely close. So it's kind of riding along that horizontal axis there. And then it starts to very slowly grow, and then it begins to grow really quickly. And it goes infinitely on both ends. Okay? Our next graph is y equals 1/2 to the x power, and I actually want to have parentheses around 1/2 and that x outside the parentheses. So that way we make sure that x is actually, that x power is actually applying to the whole fraction, top and bottom. Okay, so again we're going to make an xy table, and I like to start out with 0. You don't have to. But 0, anything to the 0 power is 1. So 0, 1. Okay, and then next we'll use the first power. So we've got 1/2 to the first power, that's 1/2. So 1, 1/2. Okay, the second power. So 1/2 to the second power, and we're raising the top to the second and the bottom. 1 to the second power is 1, 2 to the second power is 4. 1/4. 3. 1 to the third power is 1. 2 to the third power is 8. So at 3, we have an output of 1/8. So the right side of the graph looks like this. Okay. Then on the left side of the graph, negative 1. 1/2 to the negative 1 power, and we'll use the calculator. So use the fraction button on there. So 1 over 2, and I really should have put that in parentheses, so I'm going to start that over. So parentheses, then the math button, over 1 to the bottom of the list gives me a fraction, 1 over 2. Then I'll get out of that fraction, close the parentheses, and raise to the negative 1 power, and that is 2. Negative 1, 2. Okay, I can also put 0.5 in the calculator instead of 1/2, so when I do the negative 2 power, I'll just do 0.5 to the negative 2, and I get 4. Okay, then I'll do negative 3 and then negative 4. So 0.5 raised to the negative 3 and 0.5 raised to the negative 4. So for negative 3 as an input, I get an output of 8. Negative 4 as an input, I get an output of 16. Okay, so I've got negative 3, 8. And then I've got negative 4, 16. And again, it only goes up to 13. So 14, 15, 16. So right about there. And then arrows on both ends. Now this first one, from left to right, it is growing. This is called exponential growth. This one is shrinking from left to right. This one is called exponential decay. Okay, so exponential growth occurs when the amount added is proportional to the amount that already is present. Exponential decay happens when the amount of decrease is proportional to the amount present. Okay, so we are going to determine whether each function represents exponential growth or exponential decay. Okay, so there's a couple ways to do this. So I'm going to show you by making an XY chart, and then we'll talk about just a shortcut to be able to look at the equation and know if it's exponential growth or decay. So I'm going to do an XY chart using 1 and 2 as my inputs for each of these. Okay, so when I have an input of 1, 1/5 to the first power is 1/5. 1/5 to the second power, if I do top and bottom both to the second power, I get 1 over 25. Okay, so notice as my input increases, my output decreases. That output got smaller. That is decay. Okay, so next up, 3 times 4 to the first power. 4 to the first power is 4, and 3 times 4 is 12. Remember, order of operations, always do that exponent first. Now the second power. So we've got 4 to the second power, which is 16, and 3 times 16 is 48. As my input increases, my output increases. That is growth. And our last one, 7 times 1.2 to the x power. So when I put in the first power, I'll just go ahead and do this one in the calculator. 7 times 1.2 raised to the first power is 8.4. Okay, then 7 times 1.2 to the second power is 10.08. So when my input increases, my output also increases. That is exponential growth. Okay, so a shortcut. What I want you to notice in this case right here, this input or this fraction here that's being raised to the power, that's not the input, but when this right here is raised to a power, that number that's being raised to a power is a number that is less than 1. Actually, it's between negative 1 and 1. That's what I should say. So it's greater than negative 1, but it is less than 1. And I probably shouldn't use an x here either, so I'll just put a little number symbol. That number right here is between negative 1 and 1, and that gives us decay. Okay, now this number here is not between negative 1 and 1. Okay, so its absolute value, that's another way to say it, that the absolute value of that number is greater than 1. And that gave us growth. Okay, so this one, if I wanted to write with absolute values, it would be the absolute value of that number is less than 1. So when that number has an absolute value less than 1, it's decay. When it has an absolute value greater than 1, it's growth. And in this case, once again, we have a number whose absolute value is greater than 1, and that gives us exponential growth.